Hey, what is going on, guys? Welcome to yet another episode of Q Learning. And we have finished the creating the table and updating the table, making the agent learn based on the table, updating the table, and taking actions based on the Q table. Okay, so let's just take a step back as to where we are as of now at this point in time. So, if we remember our first tutorial, we had discussed the steps we were going to take in order to create the Q learning algorithm based on our environment. And we had, spoken about all of these actions, the flow chart that we were supposed to execute, right? So, where are we at this point in time? If we can see, we had initialized the queue table, chosen and performed the action, chosen the reward, and updated the queue table. So, essentially, we have completed this uh, flow chart, so to speak, right? So, now what is next? So, where are we going next with this? So, in the last tutorial, I had told that we will start off with deep Q learning, something called as deep Q learning, and in that, it'll be exciting, right? So that was where we ended our last tutorial with. So what we are going to do this tutorial, we will start off with something called as deep Q learning. Now, if you don't have any prior knowledge to what deep learning is, I highly recommend you to check out another video where I have a video which talks about what is deep learning, and in that we are going to be explicitly focusing on something called as convolutional neural networks, in short, ConNet or CNN. So as of now, what we'll do is we'll just start off with creating the deep Q learning. So let me just create a new Python file and I'll call it as dqn. And I don't think we'll be needing this. Okay, so now here comes, in this we will learn about how do we set up a deep neural network, in so to speak, how are we going to link between our environment, that is agent taking actions, and the deep neural network that is making the the machine itself to predict the next action. So the workflow, we can say the workflow is when we create the environment, right? So what do we need in order to proceed with the environment? We need the queue table and the queue values. So what we are essentially going to do is we will develop a model which will take in our environment image as the input and throw out some Q values as the output. So if we think about it, it is we pass in the image as the input, and the model which we are going to train now will give us the Q values as the output. So let's just get started. And if you don't understand this, I have a complete video speaking about the theory and all of that involved in the video, in other video. So I highly recommend you to check it out, or else I don't think so you will be understanding what we are about to do. Okay, so let's just get started. So let's just create a class called dq dqn agent, right? And in Python, to create a class, the first letter should always be capital. Okay, and then we'll create a init method, which will take, of course, self, where we have the the class variables. So self will create a variable called self.model, and before that we'll have to be importing a couple of packages. So right off the bat, let's just go import a few packages. Let's import numpy oops as np. Yeah, numpy as np, and from keras dot backend, from keras dot backend. Oops, looks like I'm using some other interpreter, which it's not able to. Let's just go ahead and use this. I guess I have to install Gym in that case. Anyway, we'll take care of that later. Dot TensorFlow underscore backend as backend, right? And then next we'll import from Keras dot models, import sequential, import sequential, and then from Keras dot layers, import dense. We'll also add in a bunch of dropout layers. Con 2D, max pooling, or max pooling 2D, activation, activation, and flatten. FLA TTEN. Right, and we'll also import optimizers from keras dot optimizers, import Atom optimizer, and let's also import TensorFlow as TF. I think we'll also import random. Um, import random time tqdm and cv2. Let's also throw in that. Also from collections, oops, from collections import dq. This is a data structure. Also let's import os, although I don't think we'll be needing os, but anyway, just in case. And also let's import, did we leave anything else? Okay, so from pill import, not really needing that. Okay, so let's just take that off. Okay, I think these are the essential libraries or packages we need to go ahead and create our DQN, deep Q learning agent. It's short called, it is short for DQN, deep Q neural networks agent. Okay, so let's say self dot create model. I'll be creating this function, so don't worry about that. Self dot target model equal to self. Again, I'll create create underscore model. Okay, and then self dot target underscore model dot set w weights self dot model dot get weights self dot model. Yeah, great. And I'm going to be creating a bunch of, oops, that's supposed to be self. I'm going to be creating a bunch of other variables, and I'll be telling you what exactly these variables are. Memory, replay memory equal to its take pass in the DQ of max length equal to we'll say memory size. Yeah, so I will create MEMO RY size, oops, equal to, let me create about 50,000. Yeah, in Python, I just figured out a new technique where if you, let's say you have so many zeros, you can separate them out for your better understanding by putting underscores. So the interpreter doesn't still takes it as a value, I mean valid value, which is 50,000, so that it becomes easier for us to read and understand. Okay, and coming off. Right, and I'll also create another last variable, self dot, I'll call it as target update, oops, updat update counter equal to 0. I'll initialize this to 0. Okay, great. There we have our class variables initialized and good to go. Now let's create a function called create underscore model and self, of course. All right, so what do we have in this model? So in this model, what we are going to do is we are going to create the architecture of our neural network, right? So model equal to sequential, which we have imported from the Keras, and then we can just say model dot add. Let's just start off with, oops, the con 2D convolutional layer initial, and it's 256 and 3 by 3. If you, again, I'm stressing this, if you don't understand what is going on here, I would highly suggest you to go ahead and look into the tutorial where I've discussed completely on this. So we'll put the input shape that is equal to it, which is a 10 by 10 by 3. So it is a 10 by 10 RGB image. So that's why it's by 3. Okay, great. Now let's add model.add. We'll add the activation ReLU, which is short for rectified linear unit. Model.add max pooling 2D with a pool size of 2 by 2. Great. And then we also add in some dropouts. So model dot add dropout about 20%. Great. So we can just go ahead and copy and paste this. for the second con 2D layer, we don't need the input shape. Great, and everything else is the same. Okay, fair enough. And then we'll just go ahead and add the flatten. Model.add flattening, and then model.add dense. We'll add about 128 dense layers. And then the last layer, oops, model.add dense. How many layers we want is directly dependent on the number of action space, right? So how many, so it is essentially meaning that what the last output neuron should predict any of the three classes, right? So either to take the action 0, action 1, or action 2. So we have to be predicting that. So we'll just create env dot action space dot n. So uh, those many number of layers, the last layer, and then the activation is linear. Linear, great. Then we'll also do model dot compile. We'll take loss, mean squared error. This is, a bunch of actual default values. Go ahead and throw in Adam and then set the learning rate to be equal to 0 0.0, oops, 0.001, and then metrics, we will count accuracy, ACCU or ACY. Great, and then we'll return the model. Return RETURN model. Great. So now that we have created the model,